Okay, so we are starting chapter 2. Making sure we're on the right screen here. Okay, so we're looking at functions and graphs of functions. So kind of going back to lines, like what we looked at in, or what you guys would have looked at in maybe Algebra 1 or pre-algebra. And then kind of just going a little more in depth with the topic. So some vocab first. We have that a relation is a set of ordered pairs. Okay, and an ordered pair is always going to be written as x, comma, y in parentheses. And then in the ordered pairs, all of the x values are your domain values. And all of your y values are your range values. Okay, so, for example, in this relation, if we wanted to find the domain is going to be all of the x values. So we would list out all of the x values, which are the ones that come first. So we have 0, 10, 20, 30, and 40. So we just list those, separating them with a comma. And then if we wanted to find the range, we would do the same thing. Now we're looking at the y values, so the ones that are coming second in the ordered pairs. So you have 9, 6, 10, 13, and 21. Now you do not have to put them in order, but if you are looking at, let's say, something that's multiple choice, they would be in numerical order. So we would put the 6 first, then the 9, because the 6 is smaller. Now a relation is a function if each element of the domain corresponds to exactly one element of the range. That is the technical definition, but what that means is that the x cannot repeat. Okay, so if the x repeats, the relation is not a function. Okay, so if we look at this example here, we're going to look at our x values. So we have a 1, 3, 6, and 8, and we say, do any of those values repeat? No, they do not, so the relation is a function. Okay, notice we do not even look at the y's at all. Okay, we're just looking at the x values. So in example 2, we have 3, 3, and then right there, okay, the 3 repeats. So we notice right off the bat that the 3 is going to repeat, so we say that this is not a function. Okay, then we can use something called the vertical line test to determine if a graph is a function. So what you're going to do is you're going to draw a vertical line through the graph. If the vertical line touches more than once, not a function. So vertical line cannot touch graph more than one time. Okay, so if I take this and I draw a vertical line, or if I'm looking at a screen, I can just take my pencil and kind of, or my hand, kind of roll it through. Okay, but if I draw a vertical line here, okay, I'm going to touch the graph 2 times. Okay, I'm touching the graph right here and right here. And this, we're going to say, since it touches it more than once, this is not a function. Okay, the reason why the vertical line test works is because think about this if I put this as ordered pairs. Okay, so if I made the actual ordered pair for this point, this would be the point, let's say 3, 2. And then if I did the ordered pair for this point, well, that's going to be 1, 2, 3, negative 2. So if I list my ordered pairs, the x value is repeating. Okay, a vertical line is, remember, a vertical line is an x equals line. It has the same exact x value at every single point on the line. So that's why the vertical line test will work and tell you if your function is going to have any x values that repeat. So if I look at my next example, I draw a vertical line, or I roll the vertical line through the graph, and I move it through, that's only going to touch the graph one time. So we can say that this one is a function. And then two things I want to point out: because a vertical line in itself has the same x value at every single point, a vertical line is not a function. Okay, so vertical line itself is not a function. And another very common one that is not a function is a circle, because of the vertical line test. So if I draw a vertical line through a circle, I'm going to be hitting that more than once. All right, then we're going to look at function notation. So this is special notation for a function. It's going to be f parentheses x, okay, which can be read as either f of x or f at x. Okay, so it represents the value of a function for a number x. So for example, I have f of x equals x squared minus 2x plus 7. You can evaluate for f of negative 5. So what you're going to do is you're going to first plug negative 5 into the function for each x value. Let me see something here. All right, so what that's going to look like is this. You're going to go f of negative 5 equals negative 5 squared minus 2 times negative 5 plus 7. Okay, then step 2, you're going to evaluate the function, or you're just going to simplify the right side only. Okay, so I'm not even going to look at the f of negative 5, that side. I'm going to look over here to the right. I'm going to do order of operations. I'm going to do my negative 5 squared, which is going to give me a positive 25. Then I'm going to do negative 2 times negative 5, which will give me a positive 10. And then bring down the plus 7. And that's going to give me 35 plus 7, 42. And I'm going to say f of negative 5 equals 42. I am not solving for f. I am evaluating the function for the value negative 5. Okay, if this were an ordered pair, this would be the x value, this would be the y value. So we'd have the ordered pair negative 5, comma, 42. So after we plug the value into the function, the output, okay, that's our y value. And typically, you'll be asked to answer the question by just clicking in a box, and then you just put the 42 in. So let's look at example 2. Okay, so we're going to plug 2 into our function. So we have f of 2 equals -3, and then you're going to have a 2 to the 4th, and then a 2 squared, and then minus 2. So we're going to work on the right side. We'll do order of operations here. So I have a 2 to the 4th. So 2 times 2 times 2 times 2 will be 16. So we can put that in. We're going to get 16 there. So I'm going to bring down -3 times 16 plus 6 times 2 squared, which is going to be 4, minus 2. Then I'm going to do -3 times 16, which should give me a -48. 6 times 4 is going to give me a positive 24, minus 2. Okay, then -48 plus 24 would give me a -24, minus 2, that should give me a -26. So I'm going to get f of 2 equals -26. All right, next we are reading the graph of functions. We're going to read a graph just like we read a book. So we read it left to right. What you're going to be asked to do is to find the domain and range of a graph using interval notation. So remember, for interval notation, like what we did for inequalities. Okay, now with the domain and range, this is how you're going to do your interval notation. So you're going to do either a bracket or parentheses. And then for the domain, because that's your x value, that's left to right. So we would do the leftmost x. And then we would do the rightmost x. And then a parentheses or a bracket. Now, when do we use which? Okay, if you have a closed circle, you're going to use a bracket. If the value actually touches on the point, you're going to use a bracket, because think of what that is for inequalities. That's a greater than or less than or equal to. So if it equals that point, it gets a bracket. Everything else gets a parentheses. Okay, so an open circle like this one, if the graph is going to be going off the graph and you don't see where the end point is, you're going to assume that it's an arrow. And then also arrows will get parentheses as well. We're going to leave that one like that. I'm changing this graph, so keep that. Okay, so let's do the domain of this function here. So if I go left to right, I'm going to start over on the left till I hit a point on the graph. So I hit this point here, and this is the point -2, 0. I want the x value because I'm doing the domain. So this is going to be the point -2. Okay, then I'm going to make a comma. And then I'm going to keep going on the line for the graph. Okay, then I'm going to take that point and I'm going to get those values. So that looks like that's going to be the x value 1 and the y value 3. The rightmost x is a positive 1. Then I determine if I'm using a parentheses or bracket. So these both have closed circles, so these will both have a bracket. So my domain would be bracket -2, 1, close bracket. Okay, then my range is your y values. So you're going to go from down to up. Okay, so you're looking at the vertical axis. So the range, you're going to either have a bracket or a parentheses, and you're going to do the bottom y. So you're going to go bottom to top, and then the top y, and either a parentheses or a bracket. So if I go to the bottommost point, it's this same point here, -2, 0, but this time I want the y value. So my range would be 0, and then I go to the top point, which is the same point we used here, 1, 3, but I want the y value, 3. Again, they both have closed circles, so they both get a bracket. Okay, now let's look at the function on the right. That's function g of x. This is function f of x. Okay, this arrow, so if you don't have that drawn, have an arrow to include that that keeps going up and to the right or left. Okay, let's look at the domain. So the leftmost point is up here that I can see. It has an arrow, which means it keeps going. Where is it going to keep coming from? Infinity. So the infinity, though, however, is on this side of the x-axis, which is the negative side of the x-axis. So this is coming from the point negative infinity, but also up on the y-axis, going up towards positive infinity. So this would be the ordered pair when it's going off the graph on this side, or in this quadrant. Okay, so the leftmost x for this is negative infinity. The rightmost x, however, is this point right here, which looks like that is the point 1, negative 1. And I want the, so positive 1. Infinity will always have a parentheses next to it. So I get a parentheses next to the negative infinity, and we have a closed circle at the positive 1, so that will get a bracket. Now for the range, we're going to, bottommost point is this 1, negative 1. So I get a negative 1, I want the y value this time. And then I'm going to take the line, I'm going to go up here to the top. Now I'm looking at this positive infinity, because I'm going to keep going up and to the left. So negative 1, positive infinity. The negative 1, the positive infinity will have a parentheses. It's just a way to name them, so you can designate down here which graph I'm referring to. So if I look at this question, for the graph above, determine the value of f of negative 2 and g of negative 1. That means, okay, so for f of negative 2, that means on this graph named f, where is this point? Okay, so when it's given to you like this, remember you have f of x equals your y value. Okay, so what they're asking you here is when x is negative 2, so you have this point here on the f of x comma. So we look there, oh, there it is, negative 2 comma 0. So the value of f of negative 2 equals 0. And then you have g of 1, now that's saying on this graph over here to the right, that's named g of x. So this is saying, okay, when x is 1 on this graph, what's the y value? So you see 1, you have a y value negative 1. So you would fill that in as negative 1. Then for example 3, you have determine the value of x when f of x equals 2. So what they're asking you here, if we come back here, f of x equals y, now they're giving you the y value and asking for the x value. Okay, so when y equals 2, what is the x value? So in this ordered pair, fill y is 2, and this is on the f of x graph. Here's the point here for y equals 2. What's that x value? 0. 0, 2. Here is 0. And then for g of x equals negative 1, okay, when on the g of x graph, when y is negative 1, that x, we already did that right up here, so it's just positive 1. All right, so let's take a minute to work on these practice problems, and then we'll come back and do these together. Okay, I'm going to go ahead and start working these out just so we have enough time for everything today. So for the first one, we're going to plug for A, -9 in. So we're going to go f of -9 is -9 squared minus 3 times -9 plus 10. Okay, so if we evaluate on the right side, we have -9 squared is going to be a positive 81. -3 times -9 will give us a positive 27 plus 10. So that's going to give us 81 plus 27, 108, 118. What you guys got? Let me double check my head math here. There we go. Okay, 118. So f of -9 equals 118. Okay, then we're going to go to B, which is going to be f of x plus 5. So in adding this one in, or plugging this in, we're going to look like this. You're going to have x plus 5 squared minus 3 times x plus 5 plus 10. All right, so we have to work this out. So you're going to take the x plus 5 and square it. So you're going to write it twice. Okay, then you have minus 3 times x plus 5 plus 10. So you're going to want to multiply this out. So x times x is x squared. X times 5 will give us a 5x. 5 times x will give us 5x. And 5 times 5, 25. Okay, then we can go ahead and distribute this -3. So -3x. -3 times 5 will give us a -15. And then a positive 10. Then we'll want to combine like terms. So we have an x squared. We have, let's see, 5x plus 5x. That's 10x. But then we have a minus 3x here. So positive 7x. Then we have 25 minus 15. That's going to be 10 plus 10, 20. And then you're done. You don't need to factor it. And that's as much as it will simplify to. So x squared plus 7x plus 20. And then for C, you have f of -x. We plug that in. We're going to have a -x squared minus 3 times -x plus 10. Okay, so -x in parentheses, well, that will come out positive. Negative times negative. So it's going to be a positive x squared. This will become a plus 3x plus 10. So f of -x, again, is another expression. And that's going to be x squared plus 3x plus 10. Does anybody have any questions on those? All right, let's look at number 2. You're finding the values. We're going to start with f of 2. Okay, which means when x is 2, what is the y value? So we're going to come here to 2 on the x-axis. We've got this point here. So we have 2, 4. So the y value here is going to be 4. B is the same thing, f of 5. So when x is 5, what's our y value? -4, yeah. We have this point down here, 5, -4. And then for C, we have f of x equals 4. So now when y is 4, what is our x value? There's quite a few, aren't there? Okay, we're going to want to name each of those. So we have this point here, which is -6, 4. We have this point here, which is -4, 4. We have this point, -2, 4. We have 0, 4. We have 2, 4. We have +4, 4, and +6. So we would just list those separated by commas. So we would go -6, -4, -2, 0, 2, 4, 6. All right, and then in the graph, we want to provide the domain, the range, the x-intercepts, and the y-intercepts. So for the domain, okay, you're going left to right. So my leftmost point goes off the graph. When it goes off the graph, we're assuming it's an arrow. Okay, so the leftmost point here is going to be a -infinity. Same thing on the right side. Goes off the graph, so it is an arrow, so that is going to be a positive infinity. Okay, and infinity will always get parentheses. So my domain is -infinity to infinity, which we can say in words that is all real numbers. Now the range, this does not go off the graph. It's a very closed range here. What is my lowest value? Yeah, -4. And then my highest value? +4. Are we touching those values? Do we have the actual point -4, or does it just get close to it? We touch it. We're touching those values. Okay, so the range is going to be in brackets because we are including the value of -4. So bracket, -4, +4, bracket, bottom to top. Then our x-intercepts. We've got quite a few x-intercepts. Okay, they're going to start right here at -5.50. And then every one value, -4.5, -3.5, -2.5, etc. So I'm just going to say for the x-intercepts, we're going to do -5.5, 0, -4.5, 0, and then dot, dot, dot. And then my y-intercepts, I only have one y-intercept. What's that going to be? Yeah, it's right up here. Okay, we're crossing the y-axis at 4, so that's the point 0, 4. And that should be it for 2.1.